Hello students, this is the second video of G13. G13 is all about measuring three-dimensional figures. Our first video was about how to find the area of two-dimensional figures. So let's talk about the difference in two-dimensional versus three-dimensional. And to do that, I'm going to look at our formula sheet here. Okay, so this is the SOL formula sheet. I know it says 2009, but that's just when the SOLs were written, and this is our official formula sheet. Two-dimensional figures are these first 6 figures that are flat. So we're looking at the triangle, square, rectangle, circle, parallelogram, and trapezoid. So those are the two-dimensional figures. And the reason why I wanted to make sure that you could use these formulas is because you are about to see all of these shapes on a three-dimensional scale. So three-dimensional might include length, width, and height. So we're looking at 3 different dimensions. So for example, if I'm looking at this first prism here, this is called a triangular prism. Its triangle base makes it a triangle prism. And these formulas you see down below here with the capital B, that capital B stands for find the base area. So what you have to do is you have to find the area of that shaded space first before you even apply it to the formulas that we're about to talk about. So if I'm looking at this picture, the base area is the area of a triangle. So I'd have to come over here and grab the 1/2 base times height, use it to find the shaded space, take that number, and then plug it into these other formulas. So it's all very sequential. So I hope you did really well in our first lesson, or I hope you tested out of our first lesson, because here we go starting lesson 2. And this lesson is all about the surface area. Surface area and something called lateral area. So let's jot this down first. Surface area is the total area of all faces and bases of a three-dimensional shape. A three-dimensional shape. All the total area. So we're going to add up all the area of any face and base. Now the difference in faces and bases are bases, we kind of think of them as what the figure is setting on. But really what we're looking at most of the time are 2 parallel structures. So I'll show you what we're looking at when we look at an example. So we've got surface area, the total area of every surface of the shape. Then we have something called lateral area, which you might not have talked about for a long time. Lateral area is similar to surface area, except we exclude the bases. So it's just the area of the faces of a three-dimensional shape. So the total area, again, of all faces, no bases, of a three-dimensional shape. Okay, so I've taken our formula sheet, our SOL formula sheet, and I've broken it down here into all the different figures. And we're going to be doing one example per figure. Okay, so let's take a look. First, we're starting with this rectangular prism. Let's look at it on the formula sheet so you know where I'm getting it from. All right, so here on the formula sheet, the rectangular prism is on the second row all the way over to the right. Okay, so a prism is a three-dimensional figure with 2 bases. All right, so let's flip back over here. There it is. All right, so I'm looking at this rectangular prism, and check out the surface area formula. Surface area is 2LW plus 2LH plus 2HW, length, width, height. Okay, so first things first is I like to highlight what the base is, because I'm going to be solving for the lateral area, which we know has no bases. So with a prism, with a rectangular prism, you can choose any pair of congruent faces. Okay, so I'm going to choose this bottom rectangle as a base, and its matching top rectangle. These are the two bases on this shape. Okay. So if I was to solve the lateral area, let's take a look at what we're not including in this formula. I would call 10 the length of the shape. I would call 16 the width of the shape, or the height of the shape. Let's call it the height of the shape. And 5 the width of the shape. Okay, so the bases are length times width. Length times width. So over here in the surface area formula, I don't want to include the bases. So I don't want to include 2 times length times width. So my lateral area formula for this figure is going to include the 2 times L times H plus the 2 times W times H. We are not including the 2 times L times W. We are not including the bases. Okay, I'm going to switch screens real quick and go back to show you the formula sheet. There is no lateral area formula here. So you have to be savvy enough to figure out which piece to exclude. All right, so if we're solving for lateral area, let's plug everything in. 2 times our length of 10 times our height of 16 plus 2 times our width of 5 times our height of 16. Now we're looking for the lateral area, and I know this is a lot of arithmetic to do here, so I highly encourage you just to type everything in your calculator in one big line. It'll make it a lot easier. So I've got 2 times 10 times 16 plus 2 times 5 times 16. If I type it all in one line, I don't have to worry about the order of operations. The calculator will do that for me. So I got 480 as my lateral area. 480. Now remember, all area is measured in a square unit. So this would be 480 centimeters squared. 480 centimeters squared. Okay, let's take it one step further. Let's go over here to the surface area. Okay, now the surface area is the total area of all faces and bases. So looking right here at my formula, I don't need to exclude anything. I want the entire formula. 2 times length times width plus 2 times length times height plus 2 times width times height. That'll be 2 bases, 2 vertical faces, the bigger vertical faces, and 2 of the smaller vertical faces. Okay, so let's put everything in its place. 2 times length of 10 and width of 5 plus 2 times length of 10 and height of 16 plus 2 times width of 5 and height of 16. Okay. I'm going to take that equation over into my calculator. If you notice right here, guys, we already have from the lateral area, we have most of this formula. So I'm highlighting it and hitting enter, and it drops it down into the next field. So I already have the 2 times 10 times 16 plus the 2 times 5 times 16. I just need to add in the 2 times 10 times 5. This would be the 2 bases added on. Okay. I'm getting 580. 580. And of course, we're measuring in square units, so this is centimeters squared. Now, anytime you're working with something that's so concrete as a measurement, it's great to go back and think it through. We said lateral area was 480 centimeters squared, and our surface area is 100 centimeters squared more. Well, our base here, remember, it's that rectangle. Our base is a 10 by 5 base. 10 times 5 is 50. And that would be a 50 on the bottom and a 50 on the top for a total of 100 more. So it's always good to think it through, okay, so that it's not anything tricky for you. Okay, our next shape that we're going to go study is called a cylinder. Okay, a cylinder looks kind of like a soda can or a can of soup or something. And we do have 2 separate formulas for a cylinder. We have the lateral area is 2 times pi times radius times height. And surface area is 2 times pi times r squared plus 2 times pi times radius times height. So these 2 values are exactly the same. So this is my lateral area plus 2 bases. And take a look at the shape of the base here. The shape of a base is a circle. So this says 2 circles plus the lateral area. Okay. All right, so let's practice here on this shape. It's been twisted on the side, so we're going to have to be real careful when we label it. Notice that the radius comes from the center to the edge. Here you've been given the diameter, so you're going to have to cut that 15 in half. Half of 15 is 7.5. So we'd have 7.5 for each piece of the radius. And 9 is actually the height of the cylinder, even though it's on its side. Okay. The bases here are these circles. Okay. The base is the circle. So our lateral area formula does not have the formula for the area of a circle in it. Lateral area is 2 times pi times radius times height. So let's put everything in the right spot. 2 times pi times radius, which is 7.5, times height, which is 9. Now we're going to get an exact value with pi in the number, and then we're going to get a rounded value. To get the exact value, I'm going to type in everything except for pi. Get my calculator. 2 times 7.5 times 9. I'm not including pi. Not including pi. So that is 135. Since I didn't type in pi, that means pi is still in my answer. So the lateral area is 135 pi meters squared. That's called an exact answer. Okay. For the rounded answer, I'm going to go back in my calculator, and I'm just going to do the exact same thing, but I'm going to use the pi button this time. So now it's 2 times pi. Now pi is over here on the bottom of your calculator, kind of down in the alphabet. You have to choose pi. Okay, so 2 times pi times 7.5 times 9. We're going to round that to the 100th, 424.12. 424.12 meters squared. This is the rounded lateral area. So we have the exact lateral area versus the rounded lateral area. Both of them are good answers. It just really depends on the format of the question being asked. You know, if it's multiple choice and all of the answers have pi in it, you'll know how they got that. Okay. Next, let's go one step further. Let's do the surface area. Look at that surface area formula. Okay. Surface area takes into consideration the two circles. That's where this 2 times pi times r squared is. Pi r squared is your area formula for a circle, and there are 2 circles. So we're taking the 2 circles plus what we just got in the lateral area. Okay. If you're good at formulas, you can just plug everything in. 2 times pi times our radius. Remember, our radius over here is 7.5 squared plus 2 times pi times 7.5 for radius again times 9 for the height. Okay. To get an exact answer here, we might have to do 2 parts. Let's see. Get my calculator. 2 times 7.5 squared is 112.5. Okay, that 112.5 is an exact value, so it still has pi on it. That's just 2 times the 7.5 squared. Okay, I also have 2 pi times 7.5 times 9, which we already did over here, 2 pi 7.5 times 9. So I know that that piece is 135 pi. That's the lateral area. Well, these are like terms. Okay, they both have pi, so I can just add 112.5 plus 135, excuse me, for a total of 247.5 pi. Now that's our exact area. Exact area. We want to put our unit on there, that's meters squared. Okay. So to turn that into a rounded area, something with a decimal, a rounded decimal, no pi in it, I'm just going to type in 247.5 times pi. You could type the entire equation in again. You could type this whole thing in one more time with all the pi's in it, but you're going to get this value times pi. I'll show you both ways. Okay. If I type the entire surface area formula in, it'd be 2 times pi times 7.5 squared plus 2 times pi times 7.5 times 9. Okay, so that's the entire formula straight off the formula sheet, and I'm getting the same thing. So use your judgment there. Whatever mathematically makes more sense, saves you a little bit of time. Getting 777.54, and that is area, so we're measuring in squared units, meters squared. Again, you guys, we got our exact value and we got a rounded value. So just depending on what you need to answer the question, you'll know what to do. Okay, so we've looked at prisms and we've looked at cylinders. Our next shape I want to look at is called a sphere. This one down here. Okay, and you'll notice here in my sphere notes, it looks like I'm missing something. It looks like I'm missing lateral area. Well, let's think about that. Go back to your definitions if you need to. The surface area is the total area of all the faces and bases. And the lateral area is the total area of just the faces but no bases. But when we're thinking about a sphere really has no faces or bases to it. It's just all one continuous round shape. So the surface area is the full area of the surface of the sphere. All right, surface area formula is 4 times pi times radius squared. 4 times pi times radius squared. Okay, in this picture, they've given us 24 millimeters, and that's designated as the entire diameter. So half of that would be 12 and 12. So our radius here is 12. So surface area, if I put the 12 into the radius position, okay, I'm going to wind up with another situation where I might need the exact solution or the rounded solution. So first things first, let me get the exact solution. I'm going to type in everything except for the pi value. 4 times 12 squared. That is 576. 576 still has pi attached. Be careful there. You've multiplied 4 times 12 squared, and the pi is still there. So that is an exact value. Pi is still in the number. If I wanted to get a rounded value, truly something that's a little more helpful, then I would just either type the whole thing in, 4 pi times 12 squared, or just type in 576 pi. I think I'm just going to take my 576 and multiply by pi. So the rounded surface area is 1,809.56. 1,809.56. Here we've measured in millimeters squared. All right, let's flip over and we're going to finish up on the back. Okay, let's take a look at our formula sheet one more time. We can kind of check some of these off. We have worked on the rectangular prism. We've worked on the cylinder. We've worked on the sphere. I want to go back now and talk about this triangular prism. This piece of information here on your formula sheet, it looks like a triangle, but the way that they have written these formulas with the capital B in them really could be the base of any shape. So maybe you come up with a trapezoidal prism with a trapezoid as the top and bottom. You can use your trapezoid area formula to find the base area, this capital B here, and then plug that into the rest of the shape. So I'm going to show you an example using a triangular prism because it's the only one I've ever seen on the SOL before. So I've written down our two formulas over here. Lateral area is HP, where H is the height between the bases, and P is the perimeter of the base, the perimeter of just the base. Okay, so let's check that out. Lateral area is the height between the bases times the perimeter of the base. So we really need to define what the base is in this shape. Make sure when you're looking at a prism, you understand that the bases are the parallel pieces. So it's this triangle here on the front. Okay, using some spatial reasoning, if you could kind of rotate this shape around in your mind's eye and flip it so that that triangle is on the bottom, okay, you could think of that as the base, and it would match this picture a little bit better. The base is the triangle. Okay. There's its parallel partner. I'm going to highlight that in blue. Its parallel partner is here. This blue triangle. There's your second base. So one base on the top, one base on the bottom. Okay. Now, the h in this formula says it's the height between the bases. So I'm going up here to this 3. Check that out. Between the pink base and the blue base is the number 3. 3 is our height for the lateral area. That is the height between the bases. All right, the next thing we need to look for is the perimeter of the base. So let's check this out. Perimeter of the base. Well, the pink base has 5, 12, and some unknown value. And the blue base is missing the 5, it's missing the 12, but it has 10. Well, we know these two triangles have to be congruent. They have to be congruent in order for it to be a prism. So we could transfer this 10 onto this base. So the perimeter is whatever 5 plus 10 plus 12 is. Let's write that up here to the side note. The perimeter is adding all the lengths of the side together. Well, 5 plus 12 is 17, and 17 plus 10 is 27. So the perimeter value that I'm plugging in is 27. So based on your SOL formula sheet, your lateral area formula is the height between the bases times the perimeter of the bases. So I've got 3 times 27. 3 times 27 is 81. So my lateral area is 81, and we are measuring in kilometers squared. 81 kilometers squared. Okay. If we extend this to surface area, we're just adding on to the formula. This HP is the same as the lateral area. So we're saying we're taking the surface area, and we're saying whatever we got for the lateral area, that HP, plus 2 times the base area. Now, be really careful here. There is a difference between a capital B and a lowercase b. A capital B is the area of the base. The area of the base. Okay, so if we're looking at, let's take a look at this blue base up top. I'll tell you why I'm looking at the blue triangle here. The base is a triangle. Okay, so we're going to do a little breakout session for capital B. If the base is a triangle, I need to go back into my formula sheet and maybe look up what's the area of a triangle. So here's my triangle, 2-dimensional. Area formula is 1/2 base of the triangle times height of the triangle. 1/2 base of the triangle times height of the triangle. Okay, now this h is the height of the triangle. The h times p is the height between the bases. So we're really talking about 2 separate heights here. Let's finish out this breakout session. 1/2 times the base of the triangle. The base of the triangle in the blue picture is unmarked, but we know we can just copy the 12 from the other base. So the base of the triangle is 12, and the height of the triangle has been measured at 4.1. So that capital B in the formula is the result of this product. 1/2 times 12 times 4.1. 1/2 times 12 times 4.1. 24.6. So the base is 24.6. Now let's go back to the surface area formula and put everything in. Height between the bases was 3. Perimeter of the bases was 27. And now we've got our capital B as 24.6. Okay, let's put this all together. We know that 3 times 27 was 81. So you could either type in 81 or just type in the formula, plus 2 times the 24.6 we just got for B. I'm getting a surface area, a total area of 130.2 kilometers squared. 130.2. So that is the lateral area plus 2 more triangle bases. All right, almost done. Okay, next we're looking at a pyramid. All right. So the difference between a prism and a pyramid, if you take a look at the 2 pictures, is a prism has 2 parallel bases, where a pyramid only has 1 base and everything else comes to a point, just like a pyramid. All right, the formulas are kind of crazy here, so we're going to have to make sure we understand. Lateral area formula is 1/2 LP. L is the slanted height. So look at the picture here. This is something new, special to pyramids. L is the slanted height. Okay, that is not the length. It's not standing for length like in our length times width times height. This is the slanted height. P, again, is the perimeter of the base. Okay, so when we find out our lateral area is equal to 1/2 of the slanted height times the perimeter. Okay, so let's take a look at our picture here. We have not been given a slanted height. We have been given a true height. A true height goes straight down in a perpendicular path. What we need to find is the slanted height. Okay, I've just drawn in what the slanted height, where the slanted height might be. So in order to find the slanted height, we're going to have to do a little breakout session, and you've really got to use some good spatial reasoning here. I am making a right triangle inside of this pyramid. Okay, this right triangle goes down the true height, and its hypotenuse is the slanted height. Okay, another leg is here from the very center of the pyramid out to the edge. So if I were to draw that triangle separate, draw it over here, the true height of the pyramid is 3. We're trying to find the slanted height, so we need a third value, and then we'd be all set up for Pythagorean theorem. Well, we're going to get our third value from this base value of 16. If the entire length of the base is 16 and this height hits right smack dab in the middle, then it splits it into 8 and 8. So now I have enough information to do a Pythagorean theorem to find the slanted height. Pythagorean theorem is a squared plus b squared equals c squared, where c is the hypotenuse. So I'm going to use 3 as one of the legs, 8 as another leg, and I'm trying to find the hypotenuse. 3 times 3 is 9. 8 times 8 is 64. 9 and 64 make 73. So the slanted height squared is 73. To find the slanted height, I need the square root of 73. The square root of 73 is 8.544. 8.544. So my slanted height is 8.544. And now I have what it takes to put that into the lateral area formula. Lateral area is equal to half of the slanted height, which is 8.544, times the perimeter. All right, now hold on one second. Now we have to think a little bit about how to find the perimeter. Remember, this is the perimeter of the base. The perimeter of the base. So I'm going to outline the base in pink. The base is a square here. Kind of looks rectangular. It's been stretched a little bit, but I know it's a square because each side is 16. So to find the perimeter, we could just say 16 plus 16 plus 16 plus 16, which is the same as 16 times 4. 16 times 4, this should be 64. Yep, 16 times 4 is 64. So there was a lot of extra work to do. A lot of extra work to do before we could even use this formula fully. We had to do Pythagorean theorem to find the slant height, and then we had to use a little bit about this base shape to find the perimeter. Now we're all set to plug everything in all together. 1/2 times that 8.544 times 64. Final lateral area is 273.41 if we're rounding to the hundredths. 273.41, and we are measuring in feet squared. .41 feet squared. Okay, so how does lateral area stretch a little bit further into surface area? Let's take a look at the formula. Surface area is the 1/2 LP, so that is exactly the same as the lateral area. We've done all that work already, plus a base area. Surface area, 1/2 slant height times perimeter plus the full base area. So we have already done all of this 1/2 LP over here in lateral area. So I'm just going to copy all of that down again in just a minute. Before I do that, we may need to do a little breakout session for the area of this base. Okay, so I'm going to highlight the base again. The base is this square that's 16 by 16. Okay, if you look back at your formula sheet, if you have forgotten how to find the area of a square, look back. Here's our square. The area formula for a square is A equals S squared. The area is equal to a side squared. Okay, so this base area is going to equal a side squared. So that would be 16 squared. 16 squared, I believe, don't mess this up, 16 squared, I think it's 256. Yes, good, 256. So I should have everything I need now to fulfill this whole formula. We've already gotten the 1/2 LP. We already have that result. Okay, if you want to type it all in one big line, it would be 1/2 times the slanted height of 8.544 times the perimeter of 64 plus the base area 256. You could also just add these two values together. So I'm going to go up here and get my lateral area, the 273.408, and add it to the base area, 256, for a total of 529.41. 529.41. is measured in feet squared. Feet squared. Okay, we have one final shape. One final shape here. Our last shape is a cone. Let's look at this last shape. Sorry about that. Okay, so we're looking at the cone. We've got two different formulas. We have a lateral area formula. We have a surface area formula. Lateral area formula is pi times r, which is the radius, times L again, which is the slanted height. Slanted height. Okay, so let's start there. Lateral area is equal to pi times the radius times the slanted height. All right, looking at my picture, that 27.3 represents the slanted height. This 25.2 represents the true height. So what I'm missing is a radius. There is no radius given in this information. However, if I draw the radius in, I've made a right triangle again. Okay, Pythagorean theorem is everywhere, guys, so we've got to be ready to use that at any time. So Pythagorean theorem is going to help me find that radius. Pythagorean theorem is a squared plus b squared equals c squared. The a and b are the legs. The c is the hypotenuse. So you've got to decide, is the radius a leg or is it a hypotenuse? Well, since it's attached to the perpendicular measure, it is a leg. So radius is something I'm looking for. I'm going to put that in the r in the a place. The b value, I'm going to use 25.2. And the c value, which is the hypotenuse, is the 27.3. Kind of spilling over into that other picture there, sorry. Okay, so I'm going to need a little calculator help here. 27.3 squared okay, 745.29. While I'm here, I'm going to get 25.2 squared. That's 635.04. Okay, so let me switch screens here so you can see what I have. I've got r squared is equal to plus the 25.2 squared equals the 27.3 squared. To get r squared by itself, I need to subtract that 635.04 and move it over. That would leave r squared all by itself. All right, a little more calculator work. 645.29 minus 635.04. That leaves me 110.25 equals r squared. I'm almost there. I don't need r squared. I need just r, just the regular radius. So to get rid of this square, I need to take the square root on both sides. The square and the square root are inverses. They'll cancel each other off. So I need the square root of 110.25. Square root of this answer. I love this cut and paste feature. I got a radius of 10.5. Radius of 10.5. Now all of that was side work. All of that was work just to figure out what to put into the lateral area formula. So now I'm ready to figure this out. Lateral area is equal to pi times the radius we just solved for, the 10.5, times the slanted height of 27.3. Okay. Now, anytime you're working with pi, you're going to need to be able to come up with two different types of answers. You're going to need to find an exact value sometimes, and other times you can find the rounded value. So I would recommend practicing both. To find the exact value, I'm going to type in the 10.5 times 27.3, and I'm going to leave pi out. 10.5 times 27.3 is 286.65. 286.65, and pi is still part of the number. We have not yet multiplied by pi. This is considered our exact value. This is our exact value. To get a rounded value, we would just multiply the 286.65 times pi. Just multiply them together. So our answer here times pi. Final lateral area is 900.54, if you round that up, inches squared. 900.54 inches squared. This is considered a rounded value. I really know that you need to be able to do both. Okay. Final leg of this race, guys, we need to be able to extend it one step further to the surface area. Okay, so this formula, lateral area here, did not include the base. So it didn't include this circle as the base of the cone. The surface area takes that exact same lateral area, but adds in pi r squared, which is your area formula for the circle. So surface area has pi r squared for the circle. Okay, I'll highlight the base again. Here's our base. Okay, that's the piece that's pi r squared plus the lateral area, which is all the work we've already done. Pi times radius times slanted height. So we've done everything here. We just need to plug it all in. Surface area equals pi times our radius that we found here, 10.5 squared, plus pi times 10.5 times your slanted height of 27.3. Okay, we're going to work to find an exact area first. Exact area means don't touch the pi button. So I need to do 10.5 squared. Well, check this out. We took the square root of 110.25 to get 10.5. So that means 10.5 squared is just going to take us back to that 110.25. 110.25 pi. Okay, that's the first part of that equation. That is the base area there. And then I need to add in this lateral area. Now we already did this, so I'm not going to double dip here and have to do twice the work. The lateral area was 286.65 pi. 286.65 pi. Those are like terms, so we can add them together. The 110.25 and the 286.65. 110.25 plus the 286.65. Total surface area in exact format is 396.9 pi. 396.9 pi. And we're measuring in inches squared. That is our exact value. Okay. Turn that into the rounded value. Go ahead and do your multiplication. 396.9, so your answer you just got, times pi. Our rounded value is 1,246.9 inches squared. Okay, phew. Okay, I hope you took your time trying to figure out these formulas. If you get to a formula and you don't remember what it means, come see me. I would love to show you again or revisit this page with you. There's a teeny tiny little abbreviation box down here that might help you out. But this piece of paper that I'm showing you right now, this is the only formula page you get. So you need to be able to read it and apply these values. Happy studying!